Unlock the door with the key of imagination. Beyond it is another dimension, a dimension of sight, a dimension of mind. You're moving into a land of both shadow and substance, of things and ideas. You just crossed over into
Go. Right. Man, I don't understand this at all. What are even our gas laws and how do you follow them? Also, who are these people?
Yeah, I know. And is there like a secret police or something? Are we gonna get arrested? Because my mom's gonna take my phone away.
Yeah, I think I heard about them also. I wonder how you even remember when you're breaking them.
Ugh, I hate this.
Actually, let me tell you where you're wrong. Firstly, they aren't like modern-day laws. Scientific laws are statements based on repeated experimental observations that describe some aspects of our universe. He had an assistant who knew that he was crazy and would get his hopes up when he did the experiments. Dr. Zoidberg thought his assistant was really ignorant and explained the gas laws to him. His assistant was actually correcting him and knew he would learn that he was wrong.
Now let me tell you something. I know for a fact that these gas laws are correct, and I'm going to explain what they are for you, for you to comprehend. Because I know how you are, and you don't always get everything.
But I don't think that's right.
No, I know way more than you. I'm a doctor, remember?
This sort of conversation happened all the time between Alexa and the scientist. He was just unwilling to listen to her and her ideas.
And do you know how we will debunk these so-called laws?
How?
Well, we'll do it through tests, because I know that I said that we would, that they were correct, but I'm starting to rethink my opinion on it.
Okay.
All right, Alexa, you know which one we'll tackle first?
Why don't you tell me? I bet I could help with whatever you're trying to prove, but like I was trying to say before...
No, just stop, let me talk. Anyways, we're gonna do Boyle's Law first.
Okay, I know about this law. It basically states that pressure and volume of a gas are inversely proportional.
Now, I don't know what you're talking about, but what it really is that he found that the volume of an object is related to the amount of pressure exerted on the object. More specifically, it means that if there's a lot of pressure against the object, then there's a small volume present on the object.
That's what I just said, though. Were you listening?
But I don't really think that that's correct.
Okay, Mr. Know-It-All. It is correct, though, because there have been experiments done on it.
Right, but mine will debunk them and prove that they're not right. So, Beverly, the first experiment we're going to try to debunk is Boyle's Law. And do you remember what that one was?
Yeah, as pressure increases, so does volume, or vice versa. If pressure decreases and volume decreases.
Okay, so what we're going to do is I put a balloon in a syringe and to emulate an atmosphere. So if I increase the pressure by making increase the pressure on the balloon will get smaller. You can see it gets smaller because the pressure increased. Now this time we're going to prove that if the pressure decreases, the volume will increase. As you can see, it got bigger.
Look what it did. I guess you were wrong.
Okay, so maybe I wasn't exactly right, but there are still others we have to do. Okay, since you think you know everything about science and my area of expertise, why don't you do the second law? It's Charles' Law.
Sure. Well, it's also a proportion but of two variables, but instead of volume and pressure, it's with volume and temperature. And these two are directly proportional. To put this into simpler terms for you, it means when you have an object and you increase the temperature of it, then the volume will increase as well. Decrease the temperature of it, and the volume will decrease too.
Okay, well, the experiment will prove itself. Don't get ahead of yourself. We're going to get 2 marshmallows and put one in the microwave and put one in the freezer. The one we're going to put in the microwave, the volume will increase because the increase in temperature in the gas. If we put this one in the freezer, then the volume of it will decrease. Now, I will be putting the marshmallow in the microwave.
While we are waiting, I will explain how temperature affects volume. The increased temperature from the microwave forces the particles to move faster, which forces the volume of the marshmallow to increase.
As you can see, the marshmallow's volume increased. I will now put this marshmallow in the freezer to make the volume decrease.
The marshmallow in the fridge is becoming colder. This forces the particles to become closer, causing the volume to decrease.
So it's now time to get the frozen marshmallow out. You can see the volume of the marshmallow has decreased because of the temperature it is in. To prove it, to show that it did get smaller, we'll compare it to this one.
Once again, I was right.
Okay, well, I should probably trust your knowledge a little bit more.
You think?
I guess you did go to school for a little while at least, but I still know more than you. But we still have one more we need to debunk, and that's Gay-Lussac's law. I think it states that pressure and temperature are directly proportional. This means that when the temperature goes up, so does the pressure of the object because of the increased particle movement.
That's exactly right. Now that you know that they are all right, I don't think we really need an experiment for the last one. To justify this though, it's this statement based on the previous outcomes.
Yeah, you're right, but are you sure?
Yeah, I'm sure, and I'm really glad that we did that so that we could learn from our mistakes.
Well, I'm glad I had your help on this. Thank you.
Yeah, no problem. You're not so bad to work with after all.
Okay, now hopefully you guys understand where Dr. Zoidberg went wrong, but with help, he got corrected, and hopefully we all learned a thing or two about the gas laws and how important they are in our world.
Thanks, Grace, for all your help. Now, just to restate all the laws that we've learned, Boyle's law states that pressure and volume of a gas are inversely proportional.
And Charles' law states that the temperature and the volume of a gas are proportional.
And Gay-Lussac's law states that pressure and temperature are proportional and move up and down with each other.